Hello there, and welcome back. What we have in this graph is a hyperbolic hedge that's to be designed around a fountain at its center. So the center is positioned at 0, 0 there. We want to find the equation of this hedge that follows the asymptotes y equals plus or minus 2x, as you see in the dashed red lines there, and its closest point being 5 feet from the fountain. So something to remember about a hyperbola is that the points closest to the center are indeed the vertices, which are pictured here at negative 5, 0 and 5, 0. So this tells us right away that a is equal to 5. Great. So since the major axis is horizontal, we know that the equation will have the form x squared over a squared minus y squared over b squared equals 1. And so far we have that a is equal to 5, which means we have x squared over 25 minus y squared over something we don't know yet is equal to 1. So as far as finding b, remember we have a lot of options here. We don't have the foci of the hyperbola though, which means we're not going to be able to use the equation a squared plus b squared equals c squared. But we do have the slopes of the asymptotes. Now remember, given the equation of a hyperbola, the slopes of the asymptotes are either plus or minus a over b or plus or minus b over a. Now since the b squared term and the y squared term are together, and the a squared term and the x squared term are together in the standard form, we know that the slopes of the asymptotes are m equals plus or minus b over a. And we know that the slopes of our asymptotes in our specific problem here are plus or minus 2. So that means that b over a is equal to 2. Wonderful. Now we already know that a is equal to 5, so that means b over 5 is equal to 2, which means b is equal to 10. So awesome. In our equation now, which I'm going to put in a box here, we substitute 10 for b, and we get 100. So our equation is x squared over 25 minus y squared over 100 equals 1. And that equation can be used to find any other points on the hyperbola. Maybe you have a specific vertical distance from the fountain that you want to stop at for the hedges, so you could substitute to figure out where the hedges need to stop. A lot of information you can get now from the equation.